This is Professor Darrell Seitz. This Java tutorial demonstrates the stack data structure using the Java class library stack class. A stack is a last in, first out data structure. Conceptually, it's like a stack of plates on a table. And the topmost plate is where the action occurs. It's called top. You can put plates on top of the top through the push operation, or you can take plates off the top through the pop operation. Here's an example. We have a stack of numbers, and the bottom is, they're built up on top of each other. The current top right here is 23. And that's where you can pop it to get it off of there, or you can push something new on top of it. We have a stack demo class, and in there we have a stack called stack, and a stack is an example of the collection framework using generics. So this stack, we're specifying that the element type to be used is a wrapper class, an integer, so that we will effectively have integers in our stack. We have a main method, and the main method instantiates this class and calls some test methods in it. We'll be looking at each one of those. Also, this is an example of, even though it's sort of a test program, it demonstrates a composition design pattern here where we have a stack member embedded in this class, and we'll be doing stack things through the composition of having that stack present rather than any kind of inheritance from some other stack. Looking at each of these methods, first, test to add items. And the output will annotate to show what's going on. We simply push some integers onto the stack to build up the stack. We'll run it after we look at the code. Test remove items. We then pop the stack 3 times, and then we're in no danger of getting an exception because we know that we've put 6 items on it. There's definitely 3 to get off with 3 left over. Here's a remove all items. There's 2 different functions to show 2 different ways to do it. This first way has a while loop, checking on stack empty. If it's not empty, then we can continue to pop, and when it's empty, we'll be done with the while loop. The other way, what we do here is we initialize the stack so that it has the data back in it that we are testing with, and then we simply call the clear function of the stack to clear everything out. This function illustrates the last in, first out characteristics of a stack. We push, well, we have a local stack here with the same name. Of course, since it's local, it will hide the other stack in the scope here. This stack is a stack of strings. We'll push onto it the strings, the words last, in, first, out. So those get pushed on to the stack. Then we'll print out the stack at that point and then start popping it. So the last in, first out, notice we have a comment here in this annotation saying that out was the last thing put into the stack. We did last, in, first, and then finally out. That was the last thing put into it. And when we start popping it, out is going to be the first thing that's going to come out. So we'll see that the last in will be the first out. This function here illustrates that because stack is iterable, we can use a for each loop that involves an iterator. So down here we have for and then the stack, and then the elements in the stack are integers, and we have a I here to represent each element in the stack, and we're going to print out that element, and it's going to have its own toString function. Now we should understand that this is not a normal operation for a stack, because this iterator will go through the entire stack. In a proper stack, you only have visibility to its top, but it does show that for certain purposes, such as what we're going to demonstrate here, that this is available to us, because if you remember the collections framework class diagram, stack is pretty low down, and it inherits lots of implemented functions from its hierarchy that it resides in. And finally, there's a worker method in its stack that we use in some of the functions to get our stack back to its default starting state. We clear it and then add those numbers again. We're now going to look at the output. Let's run this and see how it looks. First, we see the annotation here, adding items to an empty stack. Here are the items we added. We added the label here, and this top pointer, we added that. The toString function of the stack itself gave us this string in the middle for free, with the brackets on either end and the comma separated list of the entries of each of their toStrings. So there's our stack with the top 23 here on the right. Then we're going to remove 3 items from the stack, and they're going to be removed from the top. So the 23, 44, and 100 are going to be gone, and we see just the remaining 3 items. Then the remove all makes our stack empty, and the alternate remove all through clear. First we reinitialize the stack and then clear it through that simple clear method. Here's the last in first out. You have last in first out, so out was the last in. Here's the stack at that point, and then when we start popping, out is the first out. So we see that the last in is equal to the first out, hence the acronym for the way a stack works, LIFO, last in first out. Iterating our stack down here, I'll have to expand this window slightly. The iterator goes through and traverses the stack from what in the list realm of it would be the front of the list, working towards the end of the list where the top actually is implemented. So we're going from left to right down through the list through the iteration of the stack. Again, that's not a normal stack kind of a traversal. Stacks, you just have the top. So let's go back to the code now. So back in the code to review, we've seen that we can use the stack class, generics available to us, and we can show the stack data structure its basic operations of manipulating it through its top.